Hello everyone, and welcome to today's session on Java programming. In this presentation, we'll explore how to calculate employee salary increments using classes and conditional logic in Java. The example is based on a real-world scenario provided by Spangia & Company, which offers different increment percentages based on the employee's age. By the end of this lesson, you'll be able to write a program that uses object-oriented principles, takes user input, applies decision-making with if-else statements, and displays the result in a clear format. This lesson is especially helpful for computer science students learning Java and preparing for practical applications. Let's get started. Now, let's understand the problem statement. Spangia & Company has announced an increment policy for employees based on their age. The increment is structured into three categories. Employees who are 56 years or older receive a 20% increment on their basic salary. Those aged above 45 but below 56 get a 15% increment. And employees aged 45 or younger receive a 10% increment. Our task is to write a Java program using a class to read employee details like name, basic salary, and age, then apply the appropriate increment and display the updated basic salary. This is a great example of applying real-life business rules in a Java application. To implement this program, we'll create a class named Increment. This class will contain three data members or instance variables: name to store the employee's name, basic to store their basic salary, and age to store the employee's age. The class will also include three methods. The first method, getData, will accept the employee's name, basic salary, and age as input. The second method, calculate, will determine the correct increment based on the age and update the basic salary. And finally, the display method will output the employee's name, age, and updated basic salary in a clean, tabular format. This structure follows the principles of encapsulation and clean code design. Now let's go through the algorithm that our program will follow. Step 1. Start the program. Step 2. Create an object of the class increment. Step 3. Accept the employee's name, basic salary, and age using the getData method. Step 4. Use if-else conditions to decide the increment based on the age. If the age is 56 or above, we add 20% to the basic salary. If the age is greater than 45 but less than 56, we add 15%. And for all others, we add 10%. Step 5. Add the calculated increment to the original basic salary. Step 6. Display the name, age, and updated salary using the display method. And finally, Step 7. Stop the program. This algorithm breaks the problem down into logical steps, making it easier to implement in code. Let's now begin writing the Java code. We start by declaring the class increment. Inside the class, we define three instance variables: name of type string to store the employee's name, basic of type double to store the basic salary, and age of type int to store the employee's age. Next, we define the getData method. This method takes three parameters: name, basic salary, and age, and assigns them to the respective instance variables. This helps us capture employee details from the user. In this part of the code, we define the calculate method. This method will apply the business logic for increment. We start by declaring a local variable increment to store the calculated amount. Then, using an if-else structure, we check the employee's age. If the age is 56 or above, we calculate 20% of the basic salary. If the age is above 45 but less than 56, we calculate 15%. Otherwise, we calculate 10%. Finally, we add this increment to the original basic salary, updating it accordingly. This ensures each employee gets the correct raise based on their age group. Next, we define the display method. This method is responsible for showing the final result. We begin by printing a header line with the labels, name, age, and updated basic. Then, we print the actual data, employee name, age, and the updated basic salary, using tab spacing for alignment. This clear format ensures the output is easy to read and interpret. With this method, the entire logic, from input to processing to output, is now structured inside our increment class. Now we come to the main method, the entry point of our program. We start by creating a scanner object to read input from the user. Then, we create an object of the increment class called emp. Using the scanner, we prompt the user to enter the employee's name, basic salary, and age. These inputs are passed to the getData method to initialize the employee's details. Next, we call the calculate method to compute the updated salary. Finally, we call the display method to show the results on the screen. This main method ties everything together and brings our program to life. Here you can see the complete structure of the Java program, all in one place. At the top, we import the scanner class to accept user input. Then, we define the class increment with 3 instance variables, name, basic, and age. Inside the class, we have 3 methods, getData for accepting and storing employee details, calculate for computing the increment based on age, and display for showing the output. Finally, in the main method, we create a scanner object to take user input, initialize the employee object, perform the calculation, and display the result. This condensed view helps us understand the flow of the program without going into every detail, and is ideal for revision or quick review. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. Let's take a quick look at the variables used in our program. The variable name is a string used to store the employee's name. Basic is of type double and holds the employee's basic salary. The variable age is an int representing the employee's age. We also have increment, another double, which is used to temporarily store the calculated salary increase. In the main method, we use 3 temporary variables, n for name, b for basic salary, and a for age, all of which match the types used in the class. These variables help us capture input and pass it to the class methods effectively. Here is an example of how the program works in practice. When the user is prompted, they enter the employee's name, for example, Ramesh. Next, they enter the basic salary, let's say 30,000, and then the employee's age, which is 57 in this case. Since Ramesh is 57 years old, he qualifies for a 20% increment. That means his updated basic salary becomes 36,000. The output is then displayed neatly, showing the employee's name, age, and updated basic salary. This sample demonstrates how the program applies the rules correctly and presents the result in a clear format. In this session, we built a Java program to calculate salary increments based on employee age. We defined a class called Increment, with variables to store name, age, and basic salary. We used methods to input the data, calculate the increment, and display the results. User input was handled using the scanner class, and the increment was calculated with conditional if-else logic. The final output showed updated salary information in a clear tabular format. Let's highlight some important takeaways. Always use classes to group related data and behavior. It makes your code more organized. Conditional statements like if-else are powerful tools for applying logic and business rules. Think in terms of three clear stages: input, processing, and output. Make sure to test your program with various inputs to confirm it works as expected. And finally, remember that even a simple task like calculating salary can help you develop strong, real-world problem-solving skills in Java. Thank you so much for watching this session on class as the basis of all computations using Java. I hope the explanation made the concept clearer and more enjoyable for you. All the important components, the question, algorithm, Java program, variable table, and output, are available in the description box below. If you found this lesson helpful, don't forget to like, share it with your classmates, and subscribe for more easy-to-follow programming tutorials. Every share and comment encourages more students to learn with clarity and confidence. Keep practicing, keep building, and remember, your journey to becoming a great programmer starts with mastering the basics. See you in the next session, and as always, happy coding!